Guys, now here we go to discuss the hyperbola. And here's the definition of hyperbola. Hyperbola is a set of points in a plane. The difference of those distance from fixed points called foci is constant. Okay, here's the equation of the standard form equation of hyperbolas. And look, this looks similar to the equations for ellipses, except that it has a negative sign. Yeah. And there's another thing. If you remember for the ellipses, you know that one was a line along the x-axis if A was bigger than B, right? Right. Yeah. And if A was under X, well, it's a line along the x-axis. If A was under Y, it's a line along the y-axis. But here, that doesn't matter. Here, what it matters is who is actually positive or negative. For example, this one is telling you that the hyperbola is a line along the x-axis because X is positive. And this one is telling you that the hyperbola is a line along the y-axis because Y is positive, regardless if A is much bigger than B or B is much bigger than A. That's another point. The point is who is positive. You can take that as a hint of where is your hyperbola aligned with. And here's an example. I mean, here's actually, this is here the pictorial summary of information for standard form equation 4 and 3. Well, it's actually these two equations of hyperbola. And you can see we have the vertex here, we have the focus here, we have this axis here, and the axis conjugated called here transverse axis, and the axis of conjugate. The same thing happens here. Transverse axis, conjugate axis, the vertex, and the focus. And here's something interesting about hyperbolas is that any ray that it goes here, when it hit the edge of the hyperbola, will converge at the focus. Yeah, I think it's the same principle that I use for parabolic antennas. Yeah. The same thing is used also with parabolas. Yeah, we will see that later. Interesting. Well, actually, we already saw parabolas in chapter 8. But let's keep going talking about hyperbola. So what we're going to do now is we're going to solve one example and then graph it. So let's do one of those. Okay, guys, now we have here the example. Graph the hyperbola. Well, first let's do all the things we need to do. Like, look at the hyperbola. Doesn't look like the standard form of the equation of hyperbola. Well, actually it is somehow, but the way we need to write it is like x or y divided by 144, because this has to be equal to 1, right? In this case, this has to look something like this: y squared divided by a squared minus x squared divided by b squared is equal to 1, right? So the first thing we're going to do, like we did in the previous program with the ellipses, we take this 16 y squared minus 9 x squared is equal to 144. So we divide everybody by 144. Right? And now 144 is the same as y squared divided by 9 minus 944 is the same as x squared divided by 16, and 144 divided by 144 is 1. So here we have that a squared is equal to 9, so a is equal to plus or minus 3. B squared is equal to 16, so b is equal to plus or minus 4. Well, this doesn't help much, but you will see why I'm writing these numbers here. Now, well, if we want to calculate the focus for a hyperbola, the focus c squared is equal to a squared plus b squared. Yeah, you remember the other one was a minus b squared, and this one is plus. This is, remember, this is hyperbola. So in this case, you want to calculate this one, it's going to be c is equal to the square root of a squared plus b squared. This is going to be equal to the square root of, well, we have 9 plus 16. Oh, isn't that 25? Isn't then the focus 5? Plus or minus 5. Because we know we have one here and the other here. Oh, well, actually, it's aligned the y-axis. One here, the other one there. Okay. So let's keep going. What we're gonna do is graph it. So let's go here. The vertex. Here we have 1. X is plus or minus 3. Good. The other thing is, I said we calculated a moment ago 4 and minus 4, and you say, well, we don't need those because the hyperbola is going to be along these two, being along the y-axis. But you know, it would be good because if you add this one and you do this here, here, here. Oops, took me long. And you go here. Okay, we have this rectangle, and you say, well, this rectangle doesn't help me much, but from this rectangle you can get the two asymptotes. You wanted to go something like, okay, stop in a second, that's wrong. Let me try. Here I draw those asymptotes. Why I want to draw those asymptotes? Because we know that the graph is going to start from 3, right, from point 3, and it will go all the way asymptotically to this line, and all the way asymptotically to this line. The same thing here, start from -3, all the way asymptotically to this line, all the way asymptotically to this line, and that's actually our hyperbola. If you look at this example, it's actually from the PowerPoint. If you look at the PowerPoint, they did something like that. So it would be good when you're trying to graph the hyperbola, find A plus or minus 3 and B plus or minus 4 in this case, and make the square, you know, it's going to be, or rectangle in this case, it's going to be a line along the y-axis, but it will be much easier to see. Now we know that the focus here is in 5, so the focus will be here and here. And that's it. This is the vertex, and those are the hyperbola. Okay guys, that's all for hyperbolas. Check the PowerPoint, there's other examples there. And anyway, if you have questions, just send me an email. Okay, take care guys.